Hello students, welcome to our mathematics lessons. We want to give the correct solutions to the assignment given. Just only 4 of them, as simple as they are. Our subject is mathematics. And the subject, as you know, is fractions. Solutions to the last assignment. Number 1. What was given there was 17 over 19 as number 1. And then we saw that that one is a proper fraction. Proper. Why is it proper? As we told you, numerator is smaller than denominator, or denominator is larger than numerator. Number 2, we are given 19 over 17. This is improper fraction. Of course, you know, here now, the numerator is greater than the denominator. The load the leg is carrying is more than the leg can carry. That is that improper fraction. Number 3, we have 2 whole numbers, 17 over 18. This is a mixed fraction. Why is it mixed fraction? We have the whole number portion. We also have the proper fraction aspect of it. So 2 things there. Whole number, proper fraction. So that is in order. So we write this, a good example of mixed fraction. Number 4, we have 3 whole numbers, 18 all over 17. We are told that a mixed fraction should consist of 2 things, a whole number portion and a proper fraction portion. Here is improper, attached to whole number. This is not a mixed fraction, not mixed. So if you got all this, then it means you are following and you have 100%. We shall now clean up this and move on to the very aspects for today. I hope you have taken notes of the corrections. If there are any that you got wrong, you take note and make the necessary correction. For today, proper, we shall look at the following. And this is the guideline that we shall follow. Expressing a mixed fraction as an improper fraction. Expressing an improper fraction as a mixed fraction. There's 2 of them there. Equivalent fractions. And reducing a fraction to the lowest term. Number 4, arrangement of fractions in order of magnitude, either from small to bigger values, ascending order, or from larger values to smaller values, which is descending order. And number 5, which is the last aspect we hope for today, we shall add and subtract some simple fractions. All right, we take off. First one, expressing mixed fraction as improper. Mixed fraction. Let's take example 1, e.g. 1. We have 2 whole numbers, 3 over 4. Let's see whether this is a mixed fraction. Whole number is there, correct. Proper fraction there, correct. Therefore, this is a mixed fraction. We now want to change this to an improper fraction. Remember that the improper fraction is that fraction where the numerator is bigger than the denominator. Now, we see in the proper fraction portion, we have a numerator there. We have a denominator there. We start from the denominator of the proper fraction part of a mixed fraction. That's where we start. What is the denominator there? The denominator there is 4. That's where we start, with 4. What's the relationship between this 4 and this 2? The 4 here should multiply this 2. So, step 1 in this. Step 1, we multiply the denominator 4 by the whole number portion. That is step 1. And what does this give us? 8. We put it down. Noted. Then what about the 3 remaining there? We are looking for a numerator, something that will be on top. And it will be on top of this 4 here. Therefore, step 2 now. Step 2. What do we do? This 8 is added to this 3 to produce a number 11. Remember, we are looking for an improper fraction. So is this last answer now? Step 3. We write the whole improper fraction now as 11 when 4 was dividing. So there are 3 steps that we have passed through, or we should pass through. First, multiply the numerator of the proper fraction by the whole number portion. Get your answer ready. Then next, add whatever answer you had there to the numerator of that proper fraction. That is the final numerator you'll be having in your answer. Then write that numerator over the denominator of the proper fraction. That gives you the improper fraction resulting from the mixed fraction. All right. We know that with this you can do a number of other problems. But for time's sake, we shall move on. And you will try to change some of them. Now we want to reverse what we have done. What we have done. We want to reverse it. We now have EG2. What are we looking for in EG2 now? We are moving into changing improper fraction to a mixed fraction. In doing this, we must always follow long division method. No short division. Because experience has shown that the short division, students make very many mistakes. They will be dividing, certain things carry over in their memory. They are not seeing it. So due to play, they can forget. So this particular thing now, we are going to use long division. What we have still on the board, we are using long division to work it. You draw this particular shape that I have drawn, which indicates the symbol for long division. Inside it is what I'm going to write, the numerator. Inside there, numerator. Then outside it, some textbooks will put a cup there, so that the thing does not fall away. You put the thing inside the cup for it to remain there, so that it doesn't fall away. You don't forget. You put the 4 there, which is the denominator of that improper fraction. Then you say 4 will divide 1. Take the digits inside there 1 by 1. Don't say 4 into 11. 4 will divide 1. It cannot. You are not writing anything. Then now you are taking 2 digits. 4 will divide 11. Don't be in a rush to take the whole thing. That will cause trouble. 4 into 11, you may not know what it is. Don't feel ashamed to use your fingers to help you, or do the nursery type of counting. 4 times 1, 4. 4 times 2, 8. 4 times 3, 12. If you say 4 times 3, 12, 12 is greater than what is inside there. Therefore, it cannot be 3 times. It should be 2 times. Then you write the 2 on top of the second digit. Because it's the 2 digits they are dividing, not the 1 digit. On top of it. Then you do that your multiplication once more. 4 times 2, 8. What is the next work that we are to do? We are to subtract. Put the sign of subtraction so that you don't forget. 11, take away 8. There are people who find it very difficult to do that. Don't feel ashamed at all. Draw your usual 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You are taking away 8. 1, 2, 3, 4, 5, 6, 7, 8. Ask yourself, what is remaining? The ones that were not crossed. Come under and count it. Come under and count it. 1, 2, 3. Okay. So what remains here is 3. So our division is finished. We shall now write our answer. How many whole numbers had we? We had the one on top, 2 whole numbers. After dividing, was there anything remaining? Yes. What was remaining? 3. Put it there. What number were we using in dividing? The one inside the cup. And what is that thing inside the cup? 4. So we have now changed our improper fraction to a mixed fraction. That is the method for handling these changes. For example 1, we changed a mixed fraction into improper fraction. For example 2, we changed improper fraction to a mixed fraction. So let us go on to the next aspect. In the next aspect, we shall handle equivalent fractions. What are equivalent fractions? Fractions that are equal in value with the original fraction, but they have different numerators and denominators from the original. Equal in value with the original, but they have different numerators and denominators from the original. This involves multiplication table. It involves division table. If we are ranging from smaller to bigger, we are ascending. If we are ranging from bigger to smaller, we are descending. When we are ascending, we multiply. When we are descending, we divide. Ascend, multiply, descend, divide. Ascend, multiply, descend, divide. That is the rule. If we remember this, it's a very simple problem. Provided that we know our multiplication table, there is no magic about it. We must know it. Right. Let us take some examples here. Examples. That is equivalent fractions. Equivalent. So if we look at it from the Latin expression, equal, valente, that is power, strength, equal in power, equal in strength. That means equal in value. That is the meaning of equivalent. So looking at it, equivalent fractions. Let's take example 1 for this. Suppose we are given 3 over 4. This is a proper fraction. And they want us to write a number of fractions that are equivalent to this. Now, we are moving in an ascending. You can see this 3 on top, 4 below. There's nothing that can divide 4. Nothing can divide 3 without a remainder. So this thing here is a proper fraction in the lowest form. Therefore, if we are trying to get others now, we are going to get higher numbers. So, in ascending order now. All right. We say what we have here is equal to. Remember I mentioned that it is use of multiplication table. If you multiply 3 by 1, it remains 3. If you multiply 4 by 1, it remains 4. It therefore means that whatever you use in multiplying numerator, that is exactly what you shall use in multiplying denominator. You don't use 2 to multiply numerator and use 3 to multiply denominator. No way. Because it can no longer be equivalent. It will not have equal power, equal strength, equivalent. Therefore, if I decide to multiply 3, which is numerator, by 2. I shall have here 3 multiplied by 2 for the numerator. Because I use 2 in multiplying 3, I must also, whether I like it or not, use 2 to multiply 4. So this here now will become 4 multiplied by 2. And what am I now having? I'm having 6 all over 8. Therefore, this fraction now, 6 over 8, is equivalent to 3 over 4. Suppose I say that I don't want that. What I want is to multiply 3 by 3. 3 by 3. What shall I do to the denominator? Same thing. That same number I used in multiplying numerator, I will use it in multiplying denominator. So the denominator we know is 4, but it has to be multiplied by 3. So if I do, I multiply out the top, that will give me 9. I multiply out the bottom, that will give me 12. So 9 over 12 is equivalent to 3 over 4. And also 6 over 8 is equivalent to 3 over 4. What are we saying? That whatever you use in multiplying numerator must also be used in multiplying denominator, so that none of them is cheated. You know what normally happens in our homes. When you give one person the chicken, you give the leg. The other person expecting leg. You go and give the neck. There is crisis. You give this, especially where you have twins. If you give this one orange, give the other one also one orange. If this is green, the other one should also be green. If you give this one yellow and the other one blue, crisis. Equal. Whatever you do to numerator, do to denominator. Because these numbers look like twins. They go alike. That is a fraction, original. That is the way they go. All right. We have treated equivalent fractions in ascending order. Can we have equivalent fractions in descending order? Yes, we can. E.g. 2. In descending order. Suppose I am given 25 over 30. And they want me to write this thing in descending order. So I will ask myself, what is the relationship between the top and the bottom? Is there any number that can divide this and divide this? You tell me yes. Some will say 5. Some will say many things. I know that it is 5 that can divide this. And the 5 that can divide this, how do I know? From our table of divisibility. We know that once a number ends in 0, is divisible by 10, is also divisible by 5. When a number ends in 5, obviously, is divisible by 5. So suppose I say 5 divided 25. I will have 5. Because I divided numerator by 5, I must obviously divide denominator by 5. If I divide the denominator by 5, that will give me 6. Therefore, 25 over 36 is equivalent to 5 over 6. Whereas the original fraction has higher numbers, the resulting final fraction has lower numbers. So it therefore means I'm moving from higher values to lower values. Whereas in the other case, I was moving from lower values to higher values. Therefore, equivalent fractions in ascending order, equivalent fractions in descending order can exist. We've taken that. Let us also think about fractions that we can ordinarily, when we see them, we say, hey, this fraction is too much. Oh. What type of fraction is this? Can we reduce fractions to smaller values so that we can know exactly how to handle them? Yes. Reduction to lowest term. What is the lowest term of a fraction? The lowest term of a fraction is that term in which it remains. There is nothing that can divide both numerator and denominator without a remainder. Then it means that such a fraction is in the lowest term. Suppose I'm given 125 over 250. Is this a fraction? Look at it very well. Is it a fraction? Yes, it's a fraction. If it is a fraction, what type of fraction is it? Numerator smaller than the denominator. Therefore, this is a proper fraction. But this is too much. Very plentiful. So, it therefore means something can happen to it. It is not stable. We have to reduce it to the lowest term. Then what shall we use in checking? We use the prime numbers. We try 2 first. If 2 is workable. After 2, you don't go to 4. You try 3. If 3 is workable. After 2 and 3, you don't touch 4. Because if 2 went, then it has taken care of Mr. 4. Then after 2 and 3, the next is 5. Like that. Until you're able to arrive at the final solution. Now looking at this. What number shall I use? Immediately I've seen 5 there. I've seen 0 there. So I'm told that 5 can divide. That is what I have gotten. So I will say, okay, how do we go there? Then I will say, this is equivalent to. I start. Can 5 divide 12? Yes. 5 into 12. How many times? 2 times. Anything remaining? Yes. 5 times 2 is what? 10. 12 minus 10 will give me 2. So 5 into 25, 5. Good. I will go to denominator with that same number, 5. Not another thing that is in our brain. 5. Whatever you did to numerator, do the same thing to denominator. So, 5 cannot divide 2. So, 5 into 25, 5. 5 into 0, 0. We look at it. Have we finally reduced it? No, nowhere. Nowhere. We now say 5 again. 5 into 25, 5. 5 into 5, 1. 5 into 0, 0. Do we leave it like this? That is the question we are asking. Do we leave it like this? Let's take again. Let's follow that step again. 5 into 12, 2. 2 remaining. 5 into 25, 5. Here, 5 into 25, 5. 5 into nothing, nothing. We are now taking 25 divided by 50. That is what we are taking. 5 into 25, 5. 5 into 5, 1. 5 into 0, 0. Do we leave it like that? No. Why? We have 5 there, we have 10 here. Why shouldn't we say no? Looking at this now, there is something common to 5 and 10. Something can divide both 5 and 10. So let's take it and see what it is. Let's take it and see what it is. 5 here, 1. 5 into 10, 2. Is there anything that can divide 5, can divide 1 and 2 without a remainder? No. This is the stable stage that this fraction is. It therefore means that our original fraction has now been reduced to its barest minimum, which is a fraction. That is the process of reducing any given fraction to the lowest term. How do we do it? We use the prime numbers. 2, check and see whether 2 can divide both numerator and denominator. If it does, continue with 2. If 2 doesn't go, then the next number to try is 3. If 3 doesn't go, you don't try 4. Why do you not try 4? Because the time you are trying 2, you will finish with all the 2's. So 4 is gone. Now you come to 5. You try 5. If 5 doesn't work, you don't go to 6. Because 2 and 3 had taken care of 6. So you now go to 7. That is the process of handling that. Now, having seen this, arrangement of fractions in order of magnitude. Arrangement of fractions in order of magnitude. Okay? That is the next aspect that we are going to now. This fraction is very wide. We are still on vulgar fractions. Decimal is there. Percentage is there. We have not even gone to those areas. Let's concentrate on this vulgar fraction and see what we can do to them. Arranging fractions in order of magnitude. Now, let us take the following. I say 3 over 4 is given to me, and 7 over 12 is given to me, and 5 over 8 is also given. Let us see 2 over 3 also given. How many fractions do I have on the board? 1, 2, 3, and 4. They want us to arrange these fractions in order of magnitude. It therefore means that we have to look for the equivalent fractions of this. And the equivalent fractions will have a common denominator for all. Common denominator for all the fractions. The first one, the denominator is 4. Second one, 12. The other one, 8. The other one, 3. How do we get that particular denominator? That is what we call least common denominator here. But in our general mathematics, we call the thing least common multiple. But here is denominators. So finding LCM of denominators, that is what you hear some books say. Now, we look at the numbers 4, 12, 8, and 3. What are they? They are the denominators of the 4 fractions. We shall now get their LCM. And of course, we know how to get our LCM. All right. Let us look at this properly. If you look at 3, 12, 4, those 3 numbers, their LCM is 12. Then what about Mr. 8? I now have 12 and 8 to look for the LCM. Then I'll ask myself, is there any number, looking at these 12 and 8, is there any number that can divide the 2 without a remainder? Remember, I told you we start with the prime numbers. And the first one we're using is 2. Let's try 2. 2 will divide 12 to produce 6. 2 will divide 8 to produce 4. Let's look at the number 6 and 4. Is there any number that can divide 6 and 4 without a remainder? That's what we're looking at. Yes, 2 can divide them. Okay. 2 will divide this to produce 3, and 2 will divide this to produce 2. Is there anything that can divide both 3 and 2 without a remainder? No. Now circle this 3, circle this 2, circle the 8, and circle the 12. We have 4 circles there. Remember, we are trying to find the LCM of 12 and 8. Let us do cross multiplication. We have seen that. Let's do another cross multiplication. We have seen that. 12 times 2, 24. 3 times 8, 24. So that is the LCM of 12 and 8. Once you have reduced the number, removing the highest common factors there, whatever remains there, cross multiply, that gives you the LCM. Therefore, the LCM of these numbers here, LCM, will be equal to 24. And that is the least common denominator we're going to use for these 4 numbers. All right, Mr. 3 over 4. You are equal to something I am able over 24. That is what we have. You see, we are trying to look for the numerator there. What did I do here? I did some cross multiplication. The same thing. Once you see equivalent fractions, cross multiply. Cross multiply. So, that will be equal to that. So, suppose I put inside there, because it's the number on top that I'm looking for. And that number on top is numerator. I call it n. If I cross multiply, I have 4 times n is equal to 3 times 24. Remember that I'm looking for n. I divide this side by 4. I divide this side by 4. Why did I divide the first side by 4? That is the number in front of the letter. And the number in front of the letter is called the coefficient. That which makes it efficient. Number so that it becomes efficient is the one that we use in dividing. Whatever you do to left hand side, do to right hand side. 4 here, 1, 4 there, 1. 1 times n, n. So equal to 4 here, 1, 4 into 24, 6. 6 times 3, 18. Aha! For Mr. 3 over 4, the equivalent fraction is 18 over 24. Okay, that's something we are doing. We shall go to 7 over 12 and do the same thing. We will now say 7 over 12 is equal to another n. So the first one should have been first n, another n, second n, all over 24. As usual, cross multiply. You have 12n2 is equal to 7 times 24. Therefore, divide by 12, divide by 12. 12 here 1, 12 there 2. 12 here 1, 12 there 1. Therefore, n2 is equal to 14. So, Mr. 7 over 12. Mr. 7 over 12, the equivalent fraction now is 14 over 24. In a similar way, we take the other ones. Now we have 5 over 8. We also say 5 over 8 is equal to another numerator, n3, inside the box, all over 24. Cross multiply again. 8 n3 is equal to 5 times 24. What is the coefficient of n3? 8. Divide by 8. Divide this other side also by 8. 8 here 1, 8 there 1. 1 times n3 is n3. n3 is equal to 8 here 1, 8 into 24, 3. 3 times 5, 15. It therefore means here again that we have Mr. 7 over 12. No, Mr. 5 over 8 is equal to, Mr. 5 over 8 is equal to 15 all over 24. It remains the last person. It remains the last person. The last person. What is that last person? 2 over 3. In a similar way, 2 over 3 is equal to another n. We took that n2, so that will give us n4. All over again, all over 24. Because that is the denominator that we want all of them to be expressed in. That was their LCM. Cross multiplying again, 3 and 4 is equal to 2 times 24. The coefficient there is 3, so divide by 3, divide the side also by 3. 3 here 1, 3 there 1. 1 times that is n4 is equal to 3 here 1, 3 here 8. 8 times 2, 16. So, looking at it, we say that the last fraction there, which is 2 over 3, its equivalent fraction with denominator 24 will be 16 over 24. Then we look at them properly now. We look at them properly now. 3 over 4, what was their equivalent there? That is 18 over 24. 7 over 12, what did we get you? That was 14 over 24. 5 over 8, what had we? That gave us 15 over 24. 2 over 3, what had we? That gave us 16 over 24. We can then write these original fractions in order, any order we want. Is it increasing order of magnitude or decreasing order of magnitude? If we want it in ascending order, it means we shall start from the smallest to the biggest. So we look at these numbers on top. All of them have denominator 24, 24, 24, 24. We shall now look at their numerators, those things that were calculated. Here we have 16, here we have 15, here we have 14, 18. The smallest is 14. Therefore, in that order, the smallest there is 7 over 12. After that, remember we took 14. We come down 15. 5 over 8. After 15, what next did we see? 16. 2 over 3. After that, what next? 18. 3 over 4. If they said we should arrange this in ascending order of magnitude, smallest to the biggest. If it is in descending order, we go the other way around. This is ascending that way, but this other one is, if we go there, coming this way, that is descending. Ascending order, smallest to biggest, descending from biggest to the smallest. That is arrangement of fractions in order of magnitude. Because of how vast this topic is, we shall now take simple addition and subtraction of vulgar fractions. Simple, not complex ones. Simple. All right, we can wipe away this and take those ones. Now, addition and subtraction of vulgar fractions. Simple ones indeed. Let's take, okay. Let's take 3 over 5 plus 1 over 5. They have common denominator. So once they have common denominator, we will write down their common denominator. Not because we are adding, you say 5 plus 5, 10. Mba. Write down their common denominator. And then look at their numerator. That is where the addition is coming. The numerator. You have shared something into a number of portions. How many are you taking? You shared them into 5. So 5. Then how many are you taking? Selecting numerator. That is where the addition comes in. Then you have the first one, 3 of it. The second one, 1 of it. So that is going to give you 4 out of the 5 of them. Very simple indeed. Can we subtract? Yes, we can. In a similar way, 3 over 5 minus 1 over 5. That is equal to, common denominator is there, 5. Don't write 10. Or you write 0. 5 minus 5, 0. It's fraction. It must have the denominator. And they have told you that they divided each of them into 5. So put the 5 there, common. Then before you start considering their numerators, it is from 3 that you're taking away 1. And your answer will be 2 all over 5. Does it mean that this is how it will always be coming? The answer is no. Certain times the fractions will be different. That was why we were able to work the other time on equivalent fractions. Let's take that time. These ones are same denominators. Here, different. Denominators. All right, we take example. We now have 4 over 7 plus 2 over 5. Let's take this. Look at it, nothing common. Both numerator everywhere. Nothing common at all. What are we going to do? Shall we add 4 plus 2, 6, all over 7 plus 2, 12? No. We would not do that. We are going to change them to have a common denominator. Just change 4 over 5 to an equivalent fraction having that common denominator. Equivalent fraction having that common denominator. So, how do we get that common denominator? Is the LCM of 7 and 5. Is there anything that can divide 7 and 5 without a remainder? No. Because there is nothing. Then the LCM is the product. 7 times 5, 35. Now watch it. That this one is slightly different from the first. This denominator now will go inside there and tell us how many times, my friend, how many times did I go inside there? 5. You write that 5. But that 5 must multiply the numerator that was there before. 4. Plus. Then this 5 will go into this 35. How many times? 7. But it will go to multiply 2. 2. So if we do that, our answer there will give us 20 plus 14 all over 35. And what will that finally give us? It will give us 34 all over 35. So if we were to subtract, you know what to do. We will not go to that. You practice that one by yourself. So what have we done? We have now done addition and subtraction of simple fractions. We will now take our small tests or assignment for these that we have done. Now for the assignment, arrange in order of magnitude A, ascending. B, descending. The following. B, or rather, is number 1. Number 2, A. Add B. Subtract very simple. I hope that as you did the first one and you got all of them correct, you will also get these ones correct. We shall also come back to try some more problems. We have not touched board mass. We reserve that for the next group of lessons. Bye. Till we meet again.